Brief introduction of myself. My name is Reza Rahman. In my day job, I am Principal Program Manager for Java on Azure at Microsoft. But actually, today's talk is not really so much about my day job. In fact, the project that I'll be talking to you about, I don't do part of my day job. I actually do that as a hobby, and I've done this project as a hobby for I think almost 10 years now. Actually, originally I started this project at when I was working at Oracle, and yes, at that point in time I was doing this job, working on this project in my day job, but now I'm not. Right, and I think it's been almost 5 to 7 years that I've just been doing this project on my own. So I would be putting a different hat on for this particular talk, and the hat I'm going to choose to put on is the Jakarta EE ambassadors. So I'll talk about the Jakarta EE ambassadors briefly, but it's basically a volunteer-driven grassroots community to help contribute to Jakarta EE in any possible way, including in this project. So there's my contact information if you want to reach out to me a bit later after this talk. This is one of the reasons I'm here doing this talk with you, is to connect with you in person. So you can reach out to me via email, you can DM me on Twitter, whatever you want. If you go onto my website, I have a little website, there's a contact page there. There's many different ways you can contact me. If you even want, you can be old-fashioned and pick up the phone and give me a call, and I'm okay with that too. So here to connect with you, please do take advantage of that. Today, not really my day, not really presenting as Microsoft necessarily, but really more as a Jakarta EE ambassador. Okay, so what is this talk about? Let's discuss that in a moment, sort of to motivate you on why you should invest the next 50 minutes here. So this talk is about a mashup of a couple of different important concepts that I feel passionate about for a little while now. One is Jakarta EE. So we will be talking about essentially how to do a specific design technique in the context of Jakarta EE. Okay, so you can derive some things out of this talk even if you're not using Jakarta EE, but ideally a lot of it actually is very specific to Jakarta EE as a technology. If you're using something else, you can quite possibly take maybe about 60 to 70% of this talk and do some extrapolation to say, hey, how does this apply to my particular technology of choice? And then the other important concept that we'll be talking about is domain-driven design, or DDD. Hopefully it's something that you've at least heard about before. But basically this talk is about showing you how DDD, domain-driven design, can be applied to a Jakarta EE setting. Okay, and we'll be doing that in a practical, applied fashion. So we will be talking about some concepts here and there, but actually we're talking about this with a more real-world hat on, and in terms of concrete examples of how to apply domain-driven design. Often when people talk about domain-driven design, they talk about it in a very abstract terms, and that's difficult to land sometimes. So this is where this talk aims to do actually the opposite, and in terms of talking to you about domain-driven concepts in a very example-driven practical fashion. Okay, so that's what this talk is about. I'll give you a bit more background about this talk, and then do be prepared to engage with me, because I'm going to ask you a very important question about how to conduct this session. Okay, there's a couple of different ways that we can go about this session and spend the next 50 minutes together. And I actually need your advice, okay, on what you would like to see, what of the two approaches you would like me to follow. And we'll get to that in a moment, okay? So heads up on that one. All right, so this talk is primarily about an open source project called Cargo Tracker. Okay, so the Cargo Tracker project is actually part of the Jakarta EE umbrella. It is an official part of Jakarta EE as a technology. So the Cargo Tracker project actually is a reincarnation of something that has existed for some time. And I'll talk to you, I'll tell you what I mean by that. The first reincarnation of what is today the Cargo Tracker project is actually something that hopefully a lot of you have heard of before. It's something called the Java Pet Store, all right? Or another alternative name for that is a J2EE blueprints. And I hope some of you are old enough to understand what either or both of those things are. But basically, in order to understand what the Java Pet Store or the J2E blueprints are, you need to take a time travel back with me to the early 90s, all right, when we were just beginning to do server-side development with Java and .NET, and moving away from things like CGI script and Perl and the like. So in those early days, things were actually very similar to the way things are in the world of PHP and Perl and CGI scripts. In other words, every single person that started a project or a website did things their own way, right? They applied their own design paradigms. In some cases, they didn't apply any design paradigms. And every single project looked different, right? So if you went from one website's implementation to another, you switch jobs from one company to another, every single one of these systems, although they're using the same technology in those days, basically servlets and early implementations of J2E, every single one of those systems would look different, right? And you'd have to learn a completely different new design paradigm to understand the system. So it was complete chaos and madness, honestly. So out of that chaos came order, right? What people at that same point in time, what came about was a gang of 4 design patterns. I hope some of you are familiar with that as well. And that also is a similar dynamic. It's about taking a look at software systems in terms of Java in particular, and gang of 4 largely comes from Java actually, and understanding that there are common patterns, so that not every single every single thing is different, okay, and that every single system actually has a lot of commonalities, and that is what the J2E blueprints in the end did. All right, so basically they said, okay, there are established design patterns for enterprise systems. Why don't we actually name them, categorize them, and actually provide an example of how to implement them? And that is what the Java Pet Store truly was really about. And believe it or not, a lot of those design patterns and ideas that were, I think at this point is almost 20 years old, those actually exist with us even today. And in fact, even when you are implementing DDD, which we'll talk about in just a moment, you actually still continue to use some of those same concepts that were that are actually originating in the J2E blueprints. So if you have heard terms like DAO, session facade, proxy, data transfer object, believe it or not, all of those things that we continue to use today actually originated in the J2E blueprints. So the J2E blueprints had a huge impact in our industry. It almost virtually invented the discipline of enterprise architecture almost on its own, all on its own. It's a huge accomplishment. Very few things in our industry has had that kind of impact. However, early J2E and the Java Pet Store has some specific limitations. Obviously, this even J2E was a groundbreaking concept. The concept that we even live with today, things like aspect-oriented programming, declarative programming, infrastructure as a service, right? Within delivered by runtime, those are all ideas that were actually originated in J2E as well. But J2E nonetheless had some weaknesses, right? So it was a very new API at the time. It has a lot of usability problems, and it actually, more importantly, in terms of architecture, it had some significant design constraints. So in particular, if you were using EJB2 entity beans and EJB2 session beans, it came with a certain set of design constraints. The most important one being that in a bit of something that models the data, namely entities, they could only hold data. That's it, fields. So in other words, they were simply manifestations of records, manifestations of a single row in a table, more or less. And it did not allow you to also attach behavior, okay? And that is a very serious problem because it fundamentally breaks another promise of why you would want to use something like Java in the first place, and that is object orientation, okay? And we'll talk about more about that in just a moment as to why having entities that encapsulate both the data and behavior are so intrinsically important to object-oriented design and development. So DDD is a realization of that fact. And it is also facilitated by technology. So in particular, Hibernate is the thing that enabled DDD to really happen in the Java space, because Hibernate allowed you to have entities that model the real life much more closely. In other words, you can have a POJO that doesn't have any API constraints, unlike EJB2 entity beans. And also that same entity object can manifest relationships and also manifest behavior. Okay, so this is what enabled DDD to become sort of a reincarnation and rethinking of how to design enterprise systems in the Java space. Now, the nice thing is in 2022 now, or actually much earlier than that, around I would say around the Java EE 6 timeframe, when Java EE saw its first renaissance or first reemergence as a popularly applicable technology, things like EJB3 and JPA. Since that time frame, actually now Java EE fits, or Jakarta EE these days, fits the DDD model extremely well, right? And I've observed this for almost 10 years, right? So I've been a practitioner of Jakarta EE for that period, almost that period of time. I've been doing Jakarta EE since, I've been doing J2EE since it has existed, but I've been doing Java EE and Jakarta EE since it has existed as well. And in my day-to-day projects, I've actually been applied, ever since Java EE 5, Java EE 6, I've been able to apply DDD very cleanly, right? So to me, this has been obvious for a very long time. So what I wanted to do when I joined Oracle is actually make that more common knowledge that, by the way, if you are using Jakarta EE as a technology, you can very easily fit DDD into the picture. And it's actually not just a comfortable fit, but actually a very nice fit, right, to DDD and Jakarta EE together. And the way I did that is basically I thought, okay, it's time to replace the J2EE pet store, right? So we're going to create the same type of project where we take architectural concepts in DDD and through a real world project demonstrate how it looks like, right? How do you apply it in a practical fashion? And here's an example of how you do it. So that is what the Cargo Tractor project is actually all about. And long story short, it's moved from Oracle, Java EE has moved from Oracle to now the Eclipse Foundation, and the Cargo Tracker project has also moved along with it. Right? So it is a part of the official Jakarta EE umbrella. Okay, so that is the basic gist of my talk today, right? It's about showing you in a concrete way how you can take DDD and apply it in a Jakarta EE context. Now, here's my question, and I need at least some of you to weigh in. All right, there's a couple of different ways I can run this talk. One is go with the assumption that you guys all know DDD very well, right? Other than simply having heard of it, you understand DDD. And if that is the case, I should spend more time talking about the specific Jakarta EE implementation of how DDD is applied in a Jakarta EE setting. All right, that's one option. Another option is that you have heard of DDD, but you really don't understand it that well, or you could use a refresher, right? You could use a practical implementation of what DDD actually means. If that is the case, then I should spend some time, maybe about almost half this session, getting us grounded and aligned and what DDD actually means in real life. Okay, so that is another option of how what I could do in terms of spending time with you in the next 50 minutes. So I want you to make a choice, right? So here's what I'm asking you to do. Please take the next 1 or 2 minutes, and in the chat, I would either like you to type DDD or type Jakarta EE, okay? And I want to understand which of those two directions that you want me to take. Again, DDD, if you want me to spend some time talking about DDD, Jakarta EE, if you don't want me to spend much time talking about DDD, but just talk about the Jakarta EE implementation of DDD. So go, please, next couple of minutes. Please give me your opinion. Okay, so far DDD is the winner. Okay, so if you feel strongly about the Jakarta EE direction, please pick up now. Or if you're comfortable with the DDD refresher pathway, then it's also perfectly fine. So I'm going to close it soon, but looks like DDD is the winner. All right. DDD it is. Okay, so no reason to worry. Obviously, this talk is about Jakarta EE. We will be talking about the Jakarta EE implementation at least half of the time. So no need to be too concerned. We will cover Jakarta EE, but I'll spend a little bit of time talking about DDD concepts just to get us all on the same page. And remember, again, if you have any questions or comments, you can post them in the chat, or if you're comfortable, you can also come off mute when there's a natural pause point, and I will make natural pause points on purpose. You can also come off mute and ask your question or share your comment. Okay, so what is DDD in particular? Let's talk about that in a moment. So DDD stands for domain-driven design. And believe it or not, like many things in our industry, it is simply a repackaging of concepts that have existed for a very long time. What do I mean by that? DDD is simply object-oriented development with a business focus. Let me repeat that. DDD is object-oriented analysis and development with a business focus. That's what it is. Okay. One of the reasons why you would want to be doing object-oriented analysis in the first place is to simplify software development. And how do you do that? The basic concepts of object-oriented development is that everything in the real world are really objects, and they have interrelationships. So a way of simplifying programming, simplifying software development, is to bring it closer to the real world. Right. So at the end of the day, when we're writing software, we're solving real world problems. So our implementation of our solution of the real world problem should look like the real world. So it should consist of objects and relationships. That is the heart of what object-oriented development is about. So all of those things that we talked about in terms of data, behavior, modeling the real world, inheritance, polymorphism, all of those nice object-oriented concepts, at the end of the day, its whole purpose is to allow you to create a software model of the real-world problem that you're trying to solve. Okay, and in fact, this is what domain-driven design is about. It is about understanding the business domain, understanding the real-world problem that you're trying to solve, doing an analysis of it, and creating a software model in your solution that mirrors the real world as closely as possible. So the ideal scenario of domain-driven design is where you show your implementation to a business user, and they can take a look at the implementation and they immediately understand what this software program is doing. Because everything is named the same. In DDD, it's called the ubiquitous language, right? So if you're in a hospital and you have a hospital management system, you should have your software that, there are objects that are called hospital, patient, doctor, nurse, medication, room, bed, so on. Okay, and all of your objects that are in that implementation should basically look very much like the real world. Okay, a patient has a name, a patient has a condition, a medication has dosage, a doctor has a schedule, a nurse has a schedule, so on and so forth, right? So that's how your real world implementation of your software should look like the real world problem that you're attempting to model. That's the heart of domain-driven design. So how does domain-driven design go about doing that? Well, it does it in the same way that like all other architecture disciplines do, is that they have recipes, right? And by those recipes, these are basically well understood and well named and well structured design patterns, right? It's a set of catalog of design recipes, catalog of design patterns that you apply to a known problem, to a known problem domain. So luckily, domain-driven design at this point is a relatively old discipline. Okay, so it's been around, I think, for almost 10, 15 years now. I don't actually need to invent much of this. In fact, a lot of the stuff that I'm going to show you in the next subsequent few slides is not even my own content. Okay, this is content that I'm going to basically I've repurposed from a set of resources that I'll share with you at the very end. Okay, so if you go look at those resources, you'll be able to, again, get a rehash of whatever it is that I'm trying to tell you here, and with some more detail. Okay, so first let's talk about, so these are the sets of building blocks. These are the key design arsenal. These are the key tools in your design arsenal that you need to know for DED. Okay, so let's talk about each of these in some amount of detail. So the most important concept in domain-driven design is something called an entity. Okay, an entity is really just your classical object-oriented development object. Okay, so the differences between what makes an entity though, besides being an object in the real world. So an object is a noun in the real world. I'll give you some example of that already, right? If you're a hospital system, doctor, nurse, bed, patient, medication, and so on. If you're an insurance policy, payment, risk, right? Those are all. If you're a bank, account, balance, account holder, interest rate, so on and so forth, right? Those are all basically entities, objects. Now, what makes an entity is actually somewhat technical, right? What makes an entity is that it has to be uniquely recognizable within that system. Okay, in practice, what that means is that it has a unique key in a distinctly identified database table. That's one way of thinking about it, right? So an entity should have an ID field or some kind of key field, and using that key field, you can uniquely identify that entity. And most objects that you care about are going to be like that. They're going to need to be uniquely identifiable. You're going to need to uniquely identify a given patient. They're going to have a unique ID. In real world, we all have, in the United States, you have a social security number that uniquely identifies you as a person. That is what an entity is. The other thing you need to understand is entities do have interrelationships. They're related to each other, and there's many different types of relationships you can have. You can have one-to-one, one-to-many, many-to-many relationship. And also an entity will not just have data. Okay, so this is not merely a record. An entity should have data, but also behavior. What does this entity actually do that is meaningful in your system? It should have both of those characteristics. That's what makes things closer to the real world. And we'll see that in an example of how an entity looks like and why it needs to have both data and behavior. Next thing that you need to understand is something that is very closely related to an entity, and that is a value object. So as you can gather from the name, this is also an object. Okay, so it's a noun in the real world. It has data and behavior. What is the key difference between an entity and a value object? A value object does not have an identity of its own. It does not need to be uniquely identified on its own. However, in practice, a value object is almost always has an encapsulation relationship with an entity. So a value object is almost always part of an entity. Okay, it just allows you to model things a bit better. Good example of it is, let's say, you have an insurance holder and they have a house, all right, and or they have a bank account, or they have an address. These things in an insurance-based system do not need to be modeled separately. They can simply be embedded within a policyholder object and be done with it. Address is probably the most canonical example of it. Okay, so if you have an employee in a HR system, that person, that the employee's address does not need to be uniquely identified, right? You can just have it as part of that logical record, and it's an embedded object within the employee object. It is useful in terms of modeling the real world to have it as a separate object, but in reality, it doesn't need its own ID. It doesn't need its own database record, if you will, right? So that's what a value object is. It is in a domain object, in a domain model, I'd say about 70% of 60 to 70% of things, objects are entities, but 30 to 40% are value objects, depending on the complexity of your domain. Okay. Again, if you have questions, post them or stop me. I'll be pausing in a moment and ask me questions about any of this in a bit. Okay. Next one we should understand is aggregates. So this is a realization of the fact that in the real world, in a non-trivial system, the domain model is quite complex. All right, so there's a lot of different parts of a domain model. Typically, there's in the order of, let's say, dozens. If you're in a really crazy system, maybe hundreds of entities and value objects. It's rare, right? In most of these systems, we'll talk about this in a moment. We'll talk about how microservices and things like domain context matters. But in general, a reasonable subsystem, what I will call a subsystem, probably has somewhere in the order of dozens of so entities and value objects. Each of these actually are each of these objects are actually more closely related to each other than others. Okay, so if you're talking about a hospital-based system, hospital administration is going to be a little bit different than patient management. Okay, so because of those reasons, some entities and value objects will cluster around each other more closely. So they'll have more deeply embedded interrelationships than others. And that's what an aggregate is. So you can think of it as sort of a subdomain within your domain. Okay, and each of these aggregates typically will have just one so-called aggregate root, right? One entity typically that is most important in that aggregate root. We'll see in our problem domain, right? I'll show you a concrete example of aggregates in a moment. And most systems sort of naturally evolve toward this. It's difficult to right out of the gate realize what the aggregate roots are. Typically, you will create aggregate roots as an evolutionary process, right? You'll evolve them and it will become clear what the aggregate roots are and what the aggregates are in a given system. Next concept is somewhat familiar and somewhat different at the same time. Okay, and this is what's called a repository. So a repository is very similar to J2E blueprint design pattern called data access object, or DAO. Okay, but what does a DAO do? It basically is a bridge between your object model, your domain model in memory in Java, and your database system, your tables and rows. Okay, that's the differential between these two things. And basically, it's a translation layer that takes those in-memory objects and translates them to a database implementation of it. For those of you who are really deeply embedded in Java EE, I'm describing what? I'm describing an entity manager. That's in effect what an entity manager does. And in fact, some people in the Java EE space argue that repositories, you don't actually need to implement repositories in Java EE at all, because you can just use the entity manager is the repository, right? But let's set that argument aside for a moment. So the big difference between a DAO and a repository is typically in a DAO, there is one DAO for every single entity in classical J2E blueprints. That's why that's how it's modeled. So typically for every single table, you will have a DAO. That's how it works. For repositories, it's much higher level, right? So repositories work on multiple entities at a time. In fact, repositories have a one-to-one mapping not with entities but with aggregates, right? So if you know what a particular subsystem is, typically that aggregate will have an aggregate root, and the repository actually operates on the aggregate root, not individual entities. So in other words, when you retrieve a particular part of your aggregate, you're going to retrieve actually almost the entire aggregate at the same token. right? That's how the use cases really look like. If you're going to do something, if you're going to perform an action in your system, it's going to probably be at the aggregate level, and hence it makes sense to retrieve through the repository the entire aggregate. So that's the difference between a DAO and an aggregate. And again, when we take a look at a specific example, we will see how that is, right? How repositories differ from classical DAOs. Okay. Next is factories, right? And this also again comes from the concept of an aggregate, right? So, and when you're doing object-based setup, sometimes things are as simple as instantiate an entity with a new operator, call a few simple getters and setters, and you're done, right? You have a complete manifestation of your entity. However, sometimes it's not as simple as that, and the creation aspect of entities, particularly aggregate roots, are actually a complex activity, right? So this is borrowed directly from the Gang of Four design patterns. In order to solve this problem, you need to apply a factory pattern. And again, we'll take a look at an example of this. It's literally that, right? So it's we're creating a complex aggregate. It has many different interrelationships. Instead of repeating that code over and over again, we simply put it behind a factory. All right. Last major concept I'll talk to you about with regards to the key fundamental building blocks of domain-driven design is services. Okay, and when I say services, it confuses a whole bunch of people. You know why? Because whenever we think services, we're immediately thinking RESTful services or web services. That's not what this is. Okay, so there is a concept, there is an analog to what that is. We'll talk about that in a moment. That belongs as an architecture layering concern. We'll talk about, there's a different set of design patterns that are applicable there as well. We'll talk about that in a moment. That's not the type of service we're talking about here. The type of service we're talking about here is better named, or in better terms, a domain service. Now, bear with me a second and I'll explain what this is. So as we talked about, in the real world, most things are objects. They have data and then they have behavior. The problem is, in some problem domains, there are actually verbs. In addition to nouns, there are actually verbs that are very important. All right, so in terms of a logistics-based system, usually scheduling, okay, and tracking is a very important activity. It's a verb. Scheduling is a verb. It's not a noun. Okay, schedule is a verb, is a noun, but scheduling is actually an activity. Same thing in an insurance-based system, underwriting. Okay, that's a very important activity. It's a noun. It's a thing you do. So those are actually services, right? So they are effectively, a service is just, for the most part, just one. It'll just have one method and a very complex method that it does something useful. It performs a domain service, and it will actually act on nouns, right? So these particular behaviors are not going to be embedded as behaviors within an entity, but rather they will be sort of things on their own that act on entities and value objects. So that is the difference between a domain service and an entity. They're relatively rare. Okay, I would say they occur maybe about 5 to 10% of the time, but when they do occur, they're an extremely valuable concept. So you do need to understand them. Okay, so beyond these, this is about it in terms of the key design artifacts or design patterns that you need to really understand in terms of domain-driven design. There are other related concepts that make domain-driven design more effective. Okay, one of the key ones that we'll talk about next is layered architecture. In most realistic enterprise systems, you will need to be thinking about layered architecture, and it is an optional part of domain-driven design, but only barely, right? Honestly, for most enterprise Java applications, I think you do need to think about layering, and I'll dedicate some more time talking about layered architectures in domain-driven design. I won't talk much about model-driven design and smart UI. Very briefly, You can talk the resources that I'm taking this from, the book that I'm taking this from, it'll describe those concepts in much more detail. Model-driven design is basically object-oriented design and analysis, basically, right? So whenever you're now model-driven design, some people take this to mean, oh, I must do upfront design and I must design my entire system upfront. Not the case, right? This is a mindset, right? It's a way of thinking about your problem in terms of you are always going to try to achieve a model, right? Not like you have a model out of the gate. You have to evolve and achieve a model over time. Similarly, the whole concept of a smart UI and domain-driven design is that the UI should also look like the real-world problem. It shouldn't be like some crazy UI that talks about obscure database fields. That's not how your UI in a domain-driven design should look like. Your UI in a domain-driven design should be very natural to a user, right? And even a person that is not trained in your application at all, they should be able to take a look at your UI. As long as they understand the problem domain, they should be able to say, oh, I get it. So if you're designing a cash register system, somebody who's done like a supermarket checkout, they should be able to take out your UI and say, yeah, I get it. I totally understand what this UI is trying to do. Okay, so that's what a smart UI means. All right. Before I talk about layered architecture, I'm going to pause for a minute or two and let you ask any questions. Any questions so far? Comments? You want to come off mute, ask me a question, or have a comment? Yeah, anyone? We're all good? Okay, you can always ask me questions later. So let's continue moving forward. Okay, so domain-driven design, we talked about the main parts of it, what a domain-driven design system looks like, what the design patterns are. Is that enough? The answer is, for most systems, no, right? Because if that is all you really did, I'll tell you what you will wind up with, right? And I have seen such systems in the real world. You will end up with something that I lovingly call an Uber entity. Okay, so an Uber entity looks something like this, right? It's a Java object, and you open up this Java object in your IDE, and then you see that, okay, there's a few objects and data fields and behaviors. So far, so good. But then you open up the source code, and then you scroll down, and you see, oh, this Java object is about 5,000 lines long. How come? And why is that? This is what I call an Uber entity. So the reason this is because this entity in the act of trying to implement its behavior is doing many different things, right? It's doing domain logic, business logic. It is doing coordination across different entities. It is doing UI translation. It is doing serialization, deserialization. It is doing data transfer. It is doing data storage through the interface, and so on and so forth. So each of these methods are hundreds of lines, sometimes thousands of lines long, because it is doing everything, right? It's like a super entity. It does everything. So why is that a problem? Well, while you've at the model level, your model looks quite nice, your software is still very complex to maintain. All right. So the reason this happens is because there's another way of thinking about software architecture and how you design systems, and that is along the lines of separation of concerns. Okay. So one level of separation of concerns, there's one aspect of modeling the real world, but then you also need to think about, in technical terms, separation of concerns. In reality, there are technical objectives that each system actually follows, and they are surprisingly similar, right? Across different systems, they're actually mostly the same, right? And this is where separation of concerns or layering comes into play, right? So in order to not create Uber entities, you need to separate out the distinct concerns that has nothing really to do with domain logic outside of the entity, and you need to put that in its own layer, and that is outside of the domain model. So at the lowest possible level, so if you look in my diagram, like there is a domain layer, all right? And the domain layer is where all of those things that I talked about, they mostly belong, right? So entities, value objects, factories, repositories, they all belong in the domain layer, all right? So the domain layer, though, should not have things like interface concerns, in particular user interface concerns. So by interface here, what I really mean is any kind of input and output that you have with your end system, whether that is a UI, whether that is a web service these days. If you're developing microservices, you probably are not, you don't have a UI, you have a set of services. All of those are interface layer concerns, right? So that is a specific set of concerns. Its purpose is to gain input, produce output, and do serialization and deserialization. So translate from one data format to another, right? The input data format and the output data format. And that is its purpose in life, right? So all of that code goes out of the entity and into its own layer. Similarly, in some cases, actually, what you're really doing is just coordination, right? So it's a sequence of, it is a particular use case, and in that use case, you are actually invoking more than one behavior, right? So you're invoking a set of behaviors in your domain. So you're invoking changes in the domain, behaviors in the domain that will ultimately change and ultimately result in data changes. But you're doing that at a higher level. You're doing that at the use case level rather than a domain use case level. And we'll see the distinction in a moment. So that coordination act can actually be in its own layer, and that is what is called the application layer, right? You can think about as application services. They have some similarity with the domain service, right? So an application service basically models use cases, high-level use cases in your system. We'll see that in action, and you'll see that in a moment. Again, if you take that code out of the domain model, it's going to simplify your domain model further, so you can really focus on domain modeling in the real world rather than the act of coordinating across your domain models. Finally, in software systems, of course, there's the domain model itself. We talked about the domain, all of those design patterns that we talked about before, those all belong in the domain model. And finally, there is infrastructure, okay? And in fact, Java EE, something like Java EE is actually mostly about infrastructure. So this is about different technical things: scheduling, asynchronous processing, transactions, security, monitoring, etc., logging, so on and so forth, right? These are all things that are infrastructure. These are technical concerns, right? They're almost cross-cutting concerns across the different layers. All layers produce some manifestation of all of these concerns, okay? And all of that is going to go into separate objects, okay? And it is a cross-cutting layer called the infrastructure layer, right? So any of these other layers can consume bits of infrastructure the way they want it. In case of Java EE, actually, each annotation is a representation of infrastructure. So when you put in an annotation on an entity, you put in an annotation on an interface object, really you're consuming infrastructure. Now, the other thing that people often get confused about is, like, if I say that these are layers and you should compose your system across these layers, the question is, are these mandatory? For every single domain object, must you have an interface? For every single use case, must you have an application layer? Take a look at this diagram very closely, right? The answer is, in most cases, yes, but not always. Right? So an application layer, for example, is not mandatory, right? Every single domain object does not need a corresponding interface invocation. So mostly it is a strictly hierarchical call structure, but not always, right? You can have cases where you just have an interface and it's simple enough so that you can directly make a domain object invocation. And in fact, we have examples of both cases, both structures, where you are going through an application layer and where you are not. Okay, that is about it. Now we're going to move into more of Java EE and begin to map all of these concepts within Java EE. And I noticed I'm almost out of time. So I do need to move it along a bit faster, which is okay. So any questions on any of this so far? No. Okay. So let me hurry up a little bit and get to the application real quick. Okay. So in terms of the interface layer, there's a number of Java EE APIs that implement the interface layer. Okay. So things like anything that implements faces, so a backing bean, for example, anything that implements REST, so a JAX-RS endpoint, a WebSocket endpoint, a batch interface, these are all implementations of the interface layer concerns. Those are interface layer objects. An application layer will typically be implemented by either CDI beans or enterprise beans or EJBs. That's a perfect place where you have where you're describing a use case, and that use case basically is implementing things like transactions and security. So it's a perfect place for enterprise beans. Often in application layer objects will be implemented as either CDI beans with aspects or enterprise beans. Entity has a very direct analog for the most part. There's some exceptions, but it's a direct analog in essentially JPA entities. Similarly, value objects will have a almost a direct analog in JPA embeddables. Most of Java EE has to do with infrastructure layer concerns, right? So if you have something that sends email, that is going to be its own object and using the Java Mail API. Something that does some JMS messaging, that's going to be its own object, and it's going to be consumed by others. So these are infrastructure layer concerns. And finally, repositories, right? Again, even bare entity manager, you can consider that a repository. Okay, if not, you can either use something like Delta Spike data to create your repositories, or you can hand create your own repositories using CDI. Okay, so those are the options. Bounded context, I'm going to skip over, but basically, this is a reality that most systems are complex, and most systems actually comprise of subsystems that are often separated from each other. Microservices might be a new thing, but honestly, we've been doing this for quite a while, even in terms of modular monoliths. Even if you have a monolithic application, they're actually separated by bounded contexts. Okay, so that's what that means in DDD terms. So this is the project. I'm going to jump into the project real quick. Okay, this is the project website. All right, so you can find this in the deck, or you can find it out by yourself. And over here you have an overview, all of the things that we talked about, the goals of the project. You have how do you get started with it, and it's as simple as downloading the code and running this. Okay, to run the application and begin exploring the code. If you don't want to, you can actually run the code right on the cloud. Okay, this is actually a cloud implementation of the system. There is many different aspects of it. One is the tracking interface. Okay, this gives you the tracking of the information, tracking of the cargo. If you go to the administrator interface, this tells you what all the cargo routes are. You can actually book a cargo. Okay, for a booked cargo, you can change its destination. Okay, or you can change its deadline. There's a live map, and finally, there's an interface that allows you to enter events for a bit of cargo. So you can say ABC123 is going to go into Helsinki. It's going to be loaded, unloaded, received, so on and so forth. And all of these are going to be registered within the system. Okay, so that is what the system is about. Giving you a very brief, and I'm almost out of time. If you look at the code, it will actually implement all of the layers. Okay, so there's a domain layer, application layer, infrastructure layer. You look at the domain layer, it's actually going to be broken down into aggregates. So we have 4 different aggregates. And if you look at the cargo aggregate, the aggregate root is cargo. And in the cargo object, we have both the data, right? So these are all data fields, but then there's also behavior. Okay, specify new route, assign to new route. These are all behaviors that are implemented in business, in terms of business objects. And also there's domain services that you can take a look at. Okay, so that is unfortunately all of the time that I have. I'm going to quickly breeze over the summary. Again, DDD is a good discipline. Jakarta EE is a very good fit for it, and you can start taking a look at Cargo Tracker to see how DDD fits the Jakarta EE world. And these are some resources for it in order of complexity. Okay, so I do recommend that you follow these tutorials in order, right? They're sort of increasing levels of complexity. And then if you want to learn about Jakarta EE in general, I also have a link to the Jakarta EE tutorials and examples if you want to take a look at that. Okay, that is unfortunately all the time that I have. I kind of lost track of time. So I wasn't able to cover everything that I wanted to cover. I wanted to show you some more code examples, but hopefully you can take a look at the project by yourself now that I've done an introduction and be able to see some of those patterns by yourself. So let me spin things down. If you have any last minute questions, please let me know. Otherwise, you can always reach out to me out of band and we can have a conversation out of band as well.